Alright, perimeter, circumference, and area, section 1.8. So a couple definitions from earlier that we didn't cover the whole section 1.6, but a couple definitions that are important. Perpendicular lines are two lines that intersect to form right angles, right? And the symbol for perpendicular is kind of like an upside down capital T there. So if I say, and we dealt with this in earlier in algebra, like if slope 1 is perpendicular to slope 2, you could say that. But you can also say it in terms of lines. So you can say like line L is perpendicular to line P or something like that, right? All right, so that's perpendicular. And remember that perpendicular lines intersect to form not only right angles, but four congruent angles, right? So, so we know that vertical angles are congruent, but when you have perpendicular lines, actually all four angles will be congruent, right? And the only way all four angles can be congruent and form 360 degrees is if they're all 90 degrees, right? So 90 times 4 is 360. All right. So perpendicular bisector includes or incorporates the perpendicular aspect, right, where you have where not only does it bisect, not only does it create two equal angles, but it also creates 90-degree angles. Okay, so perpendicular bisector bisects a line and creates perpendicular or right angles, and it also cuts the line in half. Okay, so if I have a line segment AB, I could have a lot of different bisectors, right, that cut the line into two equal pieces, but a perpendicular bisector is also going to create a 90-degree angle, right, and it's going to make two equal segments. All right. All right, and so so here we have our perimeter, circumference, and area formulas for some of the basic figures. So the perimeter, and we usually call it capital P. Usually capital P is perimeter, but the perimeter of a polygon is the sum of the lengths of its sides, right? And remember, a polygon is an enclosed figure with three or more segments, right? So the segments being the sides. And remember, poly means many, gon means angle, so it's a many angle figure. All right. And so the area of a polygon is the number of square units it encloses. Okay, so if, like for this rectangle here, if I broke this up into a bunch of square units, I could count those square units, and that would tell me the area, right? And we have a formula for that, of course, which is base times height or length times width. But anyway, but that's basically what we're looking at, is how many square units it encloses. All right, and for figures such as squares, rectangles, triangles, and circles, you can use formulas for perimeter. For circles, instead of perimeter, we use the word circumference, right? That's the length around it. All right, so same idea, right? Perimeter is the sum of all the sides or the length around it, and circumference is the length around the circle. All right, and then area, we have formulas for area of rectangles, triangles, circles, and squares. So here are your formulas. Square, if we know one side, right, we know all the sides. And so if we add up all the sides, it'll be, in this case, s plus s plus s plus s. And if we add those together, those are like terms, so we can just get 4s, right? So perimeter equals 4s of a square. And then the area is side times side, right? It's basically the same as a rectangle, base times height, except the base and the height are both the same. And so we multiply them together and we get side squared. All right. So rectangle, base times height, like we said. The perimeter, we don't have four equal sides, but we have two pairs of equal sides. So we know that the base is the same on top and bottom, and then the height the same on either side. So we have base plus base, which is 2b, and height plus height, which is 2h. So 2b plus 2h is the perimeter. Or you can use this formula where you where you add the base and the height and you double it, right? Same thing. All right, for a triangle, the perimeter, we don't know that any of the sides will necessarily be the same unless we have an isosceles or equilateral. So normally we just add up the sides, right? A plus B plus C. That's the formula for perimeter, okay? The formula for area is 1/2 base times height. Okay, so it's basically what a rectangle is, but we cut it in half because any triangle can be manipulated to turn into a rectangle, right? Like I could, I could just, manipulate this. Basically, you can always make it into a parallelogram. So if I just duplicated this triangle and flipped it up, it would turn into a parallelogram here. And the formula for parallelogram is also base times height, just like rectangle. So it's basically base times height, but it's just half of that base times height. Okay. So those are the formulas for triangle. For a circle, the circumference is pi times diameter. Okay, so if we take the diameter and we multiply by pi, that gives us the length around a circle. Or if we just know the radius, we can double the radius. 2 times r would give us the diameter, right? And then we just multiply by pi. So those formulas are basically the same. Kind of depends on what you're given. If you're given diameter, use this one. If you're given the radius, use this one. And then, of course, the formula for area of a circle is pi r squared. So you take the radius, square it, and then multiply by pi. All right, so those are our formulas.